identify how translations and reflections can be used to create a tessellation. And I can create tessellating patterns using 2 or more polygons. So let's take a look at our first little review. So we know that tessellations can be made with 2 or more polygons as long as the interior angles where the vertices of the polygon meet at exactly 360 degrees. We learned that from our last lesson. And just again what that looks like if we had, this is terrible drawings, but if we had 4 squares here, we know that those interior angles, here, 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 and here, that needs to equal 360 degrees. And we know because all of the angles of the square are 90 degrees, we know that that square definitely will tessellate because 90 times 4 is 360, and all the angles will equal to that on the inside. So that's just review from last lesson. Now when we're looking at actually making our tessellations, we can actually transform some of the polygons we're looking at. Now this should be a review from grade 7, but just as a bit of a refresher here, some things you can use are translations, reflections, and rotations. So let's jump into looking at what each of these actually means. So first, if we have our reflection, quite simply, it's like a mirror. It's going to kind of reverse whatever it was. So in this situation here, this one is up and down this way, and all it did was it took it and it flipped it downwards. So it's a reflection of what it would look like. If you imagine that there's a mirror right here, that's what we'd see in the mirror, is the reverse image. So it's just reflected. We've taken it and gone that way. Now, to be fair, you could have also taken this shape and reflected it this way by peeling the corners that way and flipping it side by side. But that's just one example of reflection. It's just giving it the mirror image of itself. Now, a rotation, all we've done here with this one is we've rotated it this way. So now if this was the top here, now the top is right there. It's just rotated sideways, whatever degrees. You could rotate it all the way 180 degrees, and it would look just like a reflection as well, and that can happen in the situation. But rotation is just exactly what it is, rotating in a certain amount. Now a translation is a little bit different than the other two, because in a translation we're not really actually moving the shape in a certain direction. It's actually physically moving it. So for example, in these two, right, the shape itself, polygon, didn't move. It stayed. It can just flip or rotate. In here in a translation, you are actually physically moving that shape. So if it started right here on this plane, it is actually moved over to here. Or this square started right here on spot A, and this is B and C, it moved all the way to spot C. So that's where you're actually physically moving the polygon. Whereas a reflection and rotation, you're not really moving it out of that same grid. It's staying where it is and just rotating or reflecting. Where translation, we're able to actually move it. So what does that actually mean? Well, just take a look at our translation one more time. One of the definitions that textbook gives us, and it's a really good one, is the idea that we're moving a polygon or a group of polygons a certain distance without rotating, reflecting, or altering. And that's the key thing, is when we're moving them, we're not actually rotating it and then moving. They have to stay in the exact orientation they were. So for example, if we're to move this triangle, just like that, you can see it didn't rotate or do a reflection or anything. It just simply moved from where it was. And it translated from where it was to where it is now. Or this square, if I want to translate this square, I can simply move it or slide it to the right. But again, it is not rotating or reflecting in any way. And that is a really important part about a translation, is that they're moving, but they're not changing their orientation at all. Take a look. So if we were to create a tessellation here with just a triangle, I could quite simply, well, right here, you could look at it and say, well, Mr. B, you just took that point there and you did a mirror image, so you kind of flipped it, and now it's there. So we've got, imagining that this was there, and I did a reflection. I reflected the triangle on itself if it just went that way. That's one option I could have looked at. You could also say, well, actually, you quite simply just you quite simply just translated it. You actually physically moved it over one direction, which would be the case as well. I could have moved it from here to here. But either way, I've got that there. Now all of a sudden, I've taken my triangle and I've definitely got a reflection of itself, or I could say I rotated it upside down. Then I got another one, I've put it back there and I've moved it now from here to here, or I could say I took this one here and actually just reflected it. Triangles are kind of fun that way, and you can keep going. And I can keep saying, okay, yeah, I've got these shapes and gone. So I've just moved them around. And with these ones, they could be translated, they could be reflected, or they could be rotated. But that's kind of what we're looking at, making a tessellation with triangles. We have so many options with these ones. All right, well, let's create a tessellation with more than one polygon. Well, for example, I could bring in a square, and with my square, I could add on the shape of a triangle. I could take that triangle and I could actually reflect it to make a mirror image and pop it over there. I could rotate it and pop it up on top. I could rotate it again or even reflect it and pop it on the bottom there. I could add another square that I've rotated to that side there. I could actually translate this square right here and just move it down here, and boom, there it goes. You can tell I translated it because it didn't rotate. The orientation didn't even change. It just simply moved from point A to point B without actually changing its orientation. I could then add on another square that I've rotated over there. I could actually translate the triangle from up here and just physically move it right down to the bottom. I could probably do it again for this spot. Boom, there it goes. I could take this square right here and translate it and pop it over to here. Because again, you can see that I didn't change the orientation. I simply moved it all the way there. I could take this triangle right here that's upside down, and I could actually translate that. Boom, right there. And just for fun, let's do it one more time right beside it, and boom, right there. So you can see when we're making our tessellations, you can utilize all three types of transformations to make a beautiful design here. Now, I know this is going to become a tessellation because if I look at where all those points meet, it needs to equal 360 degrees. Well, I know with the squares, that's 90 degrees and 90 degrees. And because these are equilateral triangles, I know that that's going to be 60 degrees, 60 degrees, and 60 degrees. If I add up all my angles together, guess what? I'm going to get 360 degrees. So therefore, this is a tessellation because those points all equal 360 degrees, all the interior angles. So that is it for today's lesson. Like I said, largely review from our previous lessons, but just the most important thing to remember when we're looking at a translation, you got to remember that it's physically moving the polygon, but it cannot rotate it in any way or change its orientation. So that's it. You guys check out your assignment and we'll go from there.